We're going to look at question number 6 today from chapter 21. This one asks us if we had made a decision to reject the null. We were going to fail to reject, right? We found that there were no evidence. That means we would fail to reject the null. And we're using an alpha level of 0.05, which means if we fail to reject it, our p-value has to be bigger than 0.05. Now, we don't know what that p-value is. It could be 6, it could be 12, it could be 50%. Have no idea. But we do know is it's bigger than 0.05. So they're asking us to make a decision if we had an alpha level equal to 0.1 or even an alpha level equal to 0.01, would we make the same decisions? And the reality is for this one, we have two options. Well, if our p-value falls in between 0.05, right, and 0.1, in this case, we would reject. Because our null would be less than 0.1, right? So reject, we would reject the null. However, we don't know that. It could be bigger than 0.1. If the p-value happens to be larger than 0.1, but larger than 10%, then we'd still fail to reject. If you're given a scenario like this, it's important for you to know that there are multiple options and you would be responsible for knowing those different options, and you would have to be able to kind of write those scenarios down. Okay? If, for example, here we already know that we failed to reject at 5% and the p-value has to be bigger than that, which means if I choose a smaller alpha level, it's not going to change anything. My p-value is still bigger than 5%. We would still fail to reject here. Right? So that's not going to change. So moral of the story here is if you know what the p-value is, what range it falls into, sometimes you may have two options and sometimes you will have only one. So keep in mind those scenarios, and that could flip-flop. If you turned it around, it could work out the same way in the other direction. Number 12 is about super dads, about stay-at-home dads. Spike Network did a poll, a random sample of U.S. men, and out of the 712, 22% said that they would be that they were stay-at-home dads. Part A is to help market commercial time. Spike wanted to estimate the true percentage of stay-at-home dads. Construct a 95% confidence interval. It does not say this, but that is a full-on panic part of the question. In fact, A is probably 75% of all the actual work done in this question. Anytime I ask you to do a 95% confidence interval or any kind of interval, you know that I'm going to have to do this whole bit right here. Okay, first of all, it tells me that it is randomly stated. It's stated in the problem that you did a random sample right there. Independence, well, being a dad or people's opinions about whatever, this is definitely going to be an independent situation. 10%, we know that 712 men out of all men that could potentially be dads is definitely less than 10%. Oops, left off that. There we go. For success and failure, 0.22 times 712 and 0.78 times 712 is going to give me 157 and 555. It's actually rounded a little bit, but even then, way above 10, so we're good to go on all our assumptions and conditions. We're going to be using a 1 proportion z interval to create this one. We're using 95% confidence. One thing to note, they told us here what level to use. If I am not given a level to pick from, 95% is a great one to use. It's probably the default setting. But if it's not told, you need to write it down. I make it a habit to do this every time just to make sure I don't leave it out. And I'm going to put my interval down. I went into my calculator. If you hit stat, go over to the right a couple of times to tests. If you go all the way down to find 1 prop z interval, you're going to find out you're going to input a few things. You're going to put in x, which was 157. You're going to input the total sample size, 712. And you're going to tell it 0.95 is your confidence level. That's going to generate a 0.19 to 0.125 interval. We're going to create our context, our conclusion in context. I am 95% confident that the true proportion of men who are stay-at-home dads is between 19% and 25.1%. Done. Right? That is what you would do if you're ever asked to find a confidence interval. I know it's not exactly mentioned or said in that way, but that is the expectation. Part B is asking if you had somebody that was willing to pay for commercial time, if at least 25% of men are stay-at-home dads, then use the confidence interval to make this recommendation. Now, this is kind of tricky because 25% definitely falls inside my interval. However, the advertiser wants it to be 25 and up. If I'm looking at this, then I'm looking at an interval where 25% is at the very high end. I don't think you're going to have a lot of and up to go when you recommend this to your client. 25% falls inside, but most of the interval is below. It's not above. So 25% could be the actual proportion of stay-at-home dads, but it could also be fairly low compared to 25%, but it couldn't be a lot higher than 25%. So you would be very cautious about recommending this. In fact, I probably would not recommend this if they were looking to get a number over 25. Part C is asking, despite claim to the advertisers, it's possible that 25% of men with young children are stay-at-home dads, right? Now, that seems like it's not asking very much, but what it's asking, or what it's claiming is that this is proof that 25% genuinely are stay-at-home dads. And what you would say is that this is an estimate. This is not proof. This is simply one sample. If you took another sample, that interval could be another whole percent below, or even 2 or 3% below. We don't even know. This is just an estimate. This is not guaranteeing you that 25 could definitely be the population parameter. It's just a little bit of evidence to suggest something. Every confidence interval is just a little drop of evidence in a much bigger pot. So don't ever think of a confidence interval or even a significance test as any sort of proof something is one way or another. For question number 15, this one is going to be one of those where this is not a lot of work to do. It's a lot more thinking involved. And so one of the things you have to do is you have to think about what the null alternative is. In this question, it's kind of nice. They actually kind of tell you what that is. They're going to make a decision and they're going to assume that the person gets the loan. However, if they take a certain score and that score gets low enough, they will decide not to give the person that loan, and that would be your alternative hypothesis, right? So when a person defaults on a loan, meaning they do not pay the loan back, which type of error did the bank make? Well, the bank is going to give them a loan, right? In this case, the bank made this decision because they got the loan and decided not to, right? But the reality was, the truth was that HO was false and that the alternative was true. So they failed to reject the null originally, right? When you fail to reject, right? If I can spell and talk this out, R-A-J-E-C. When you fail to reject, you're making a type 2 error. In this case, they thought he could pay the loan back, but he could not, and therefore a type 2 error was made. Okay. In part B, which kind of error is it when the bank misses an opportunity? In other words, they decide, no, you're not good enough for a loan. You have too many issues, too many red flags, so we're not going to give it to you. But the person really could. Obviously, they rejected the null. When you reject, that's just one word. That is a type 1 error. Right, so A would be this, B would be this. And part C, it says, suppose the bank decides to lower the cutoff score, meaning that if you get a low enough score, they reject the null. So it's going to be easier for you to get a loan, or it's going to be more difficult for the bank to reject your loan application, right? So that would be like taking an alpha level that originally was at 5%. Let's make it more difficult to reject. So we're going to lower that. I need a lot more evidence here. It needs to be so unusual that it only happens 1 out of every 100 samples versus 5 out of every 100. So essentially we are lowering our alpha level when we do that, right? Is this analogous to choosing a higher or lower value? It would be choosing a lower value. Now be careful. When I say lower, what I'm really saying is I'm raising the level of evidence that's required, but I'm lowering the number we call alpha, or our significance level. That seems a little counterintuitive at times, so take it slow. Make sure you understand what that statement is. In part D, it says, what impact does this change in the cutoff value have on the chance of type of error? Well, when I lower my alpha level, remember that this is your type 1 error, right? And so when we have a lower value, we essentially make it less likely to make a type 1 error, right? So this probability goes down, but for type 2 error, remember these are inversely related, we now make it more likely to make a type 2 error, right? So this is part D. This is part C. If I lower the alpha, I lower the probability of type 1 error, but I also do the inverse of that, and I raise the probability of a type 2 error. I'm also lowering my power here. Remember, type 1 and power also go hand in hand. This wasn't really about power, but just kind of FYI. Number 20. This is a great question. I use this question every year. This is very similar to styles of questions that you're going to see on the test. For number 20, for part A, well, first of all, in order for me to do this, part A has to happen first. If we're going to ever talk about type 1, type 2 errors or things like that, I have to have an idea of what the actual null and alternative hypotheses are. I can't make a decision and I can't tell you what a type error is, a type 1 or type 2 error is, without knowing it. Whenever you walk to a doctor's office, it is automatically assumed that you are a healthy individual. That's why they give you a test. If that test turns back to give you a positive result, it would mean that you have brought enough evidence for the doctor to change their mind and say you do have something, you have something that's wrong, you are sick in some way. Okay. In this example, HO is healthy and HA is that you have Alzheimer's. Part B is asking us, what would a type 1 error mean? Well, remember that type 1 is when we reject the null. So if we were to reject the null, that would mean I would conclude that the person has Alzheimer's, right? So you would conclude that the person has Alzheimer's. However, that is false, and the person is actually healthy, right? That is the truth. If I can write that word. So a type 1 error, I cannot talk and write at the same time tonight. A type 1 error, remember, is when we reject the null. If I reject the null here, I think the person has Alzheimer's. However, they are actually healthy. So I would tell someone, I'm sorry, you have Alzheimer's disease, and we're going to have to do some more tests. And they're upset, and I'm going to cost them money because they're testing things that they don't need to test. But ultimately, they will figure out that they do not have it in subsequent tests. So not absolute worst case scenario. Part C is the other side. What is a type 2 error? This would be, we fail to reject. And if I fail to reject, I'm making a type 2 error. In this example, I would say, you are healthy, right? However, that is false, and the actual truth is that you have Alzheimer's, right? That's the truth. That's actually pretty bad in that kind of situation. You would say, no, you're totally fine, go home, no big deal. They do not receive treatment. When treatment and time don't work together, time is a really bad thing with Alzheimer's. Earlier detection makes sure you get better care. So this, in case, to answer part D, type 2 error is much worse here. To determine which case is worse, you have to know context. You cannot make that decision as a blanket statement, say, oh, always type 1 or always type 2. No, it's always based on the scenario. You can't ever kind of just make those things out in one go. So, which error is which is worse? You are talking about people having catastrophic problems with type 2 errors. They do not get the health care they need, and potentially it could where they could possibly have adequate care. They may wait too long and not be able to do anything about it. Okay, part E, it says, what is the power of the test? Well, we were given two numbers, a false positive and a false negative. Well, if you remember here, this was a false positive test. I thought you had it, but you actually didn't. This would be a false negative, meaning that I said, no, you're good, but you were actually positive, right? So this is a type 2 error. Remember that 1 minus power equals type 2 error. Or vice versa, you turn that around, 1 minus type 2 is equal to power. Right? So that's great because I have type 2 error written on the paper for me. 1 minus 0.08 would equal 0.92. There is a 92% chance that if the null is false here, in other words, if they are positive for Alzheimer's, that the test will detect that 92% of the time. You'll have 8% of the time where it says that you are healthy and you are actually not. And so remember these two formulas. These are great. This is about the only way I can actually get power. If I have type 2 error, if I know type 2 error, I can get power. If I know power, I can get type 2. If I give you alpha, there is no chance, without doing some crazy complicated math, if you saw that on the type 1 and type 2 error video, that you can actually get those things out. So unless I give you the power or the type 2 error, you're probably not going to be able to find that other the connection. Alpha and beta, type 1 and type 2, do not have a really nice connection like power and type 2 do. Hope this was helpful. If you have any questions, please let me know. I'll talk to you guys later.